to some kinetic energy problems. You'll remember that the definition of kinetic energy is, get to pen here, that the kinetic energy of any object is 1/2 the object's mass times its velocity squared. So, kinetic energy is directly proportional to the mass because it's right across the equal sign from the mass, and the kinetic energy is directly proportional to the velocity squared because it's also right across the equal sign from the v squared. For this little alpha sign right here is directly, NRV, can't spell today, proportional. Now the units we're always going to use for energy are joules. Remember, kinetic energy is the energy of motion. If velocity is 0, we have 0 kinetic energy. So, suppose I have a comet that has a mass of 7.8 times 10 to the 85 kilograms. So the mass of my comet is 7.85 times 10 to the 11th kilogram. And it hits the Earth at a speed of 25,000 meters per second. What's kinetic energy? All right. Kinetic energy is 1/2 mv squared. So it's 1/2. The mass is 7.85 times 10 to the 11th kilograms times 25,000 meters per second. Should put meters per second there. So I get 2.45 times 10 to the 20th joules. Now, if the work done is 2,000 joules, so work is 2,000 joules over a distance of 0.75 meters, what's average force? Well, this isn't really kinetic energy, but it's kind of a cool problem. Work is force times distance. Force is work divided by distance. The work is 200 joules divided by the distance of 0.75. And we get 267.43 newtons. I like this problem. Cat and mouse problem. If I have a 6-kilogram cat, so my mouse is 6.0 kilograms, and it's running after a mouse, and its speed is 10 meters per second. What's cat kinetic energy? Oh, kinetic energy is 1/2 mv squared. So it's 1/2. Now we're looking for the cat's kinetic energy. The cat is 6 kilograms. 6 kilograms. The velocity squared is 10 meters per second squared. 10 squared is 100 times 6 is 600 divided by 2 is 300 joules. Now I can trip you up on a test or quiz by giving you the cat's mass as well. So make sure you identify cat kinetic energy, cat's mass, and then of course the cat's speed. Now, suppose I have a bowling ball that is 7 kilograms and it's moving at 3 meters per second. So the mass is 7.00 kilograms and my speed is 3.00 meters per second. How much kinetic energy does my bowling ball have? Well, I know kinetic energy is 1/2 mv squared. You're kind of getting the idea on these problems, aren't you? They're very straightforward. Make sure your mass is in kilograms, and you're good. Alright, so 3 squared is 9. 9 times 7 is 63 divided by 2 is 31.5 joules. Now, how fast does a 2.45 gram tennis ball have to move in order to have the same kinetic energy? So I want the kinetic energy of my tennis ball to be 31.5 joules. Now the mass of my tennis ball is 2.45 grams. kilograms, remember? As long as it's in kilograms, I'm in good shape. So I know 1,000 grams is 1 kilogram. So this is 0.00245 kilograms. So I know the kinetic energy is 1/2 mv squared. Solving this for v, v is the square root of 2 ke divided by m. I'm running out of room, or I would put that underneath. So this is the square root of 2 times 31.5 joules divided by 0.00245. Make sure this whole thing is under your radical there. You get 160.4 meters per second. Now let's calculate the speed of an, let's see, I've got this a little off here, I apologize for that. There you go. Let's calculate the speed of an 8 times 10 to the 4th kilogram air liner. We're in kilograms. And has a kinetic energy of 1.1 times 10 to the 9th joules. Okay, kinetic energy is 1/2 mv squared. Let me show you the steps for solving this. I didn't really have space on the other problem. You have a fraction, clear the fraction, multiply through by 2. So 2 times kinetic energy is mv squared. I'm looking for v. See, I'm multiplying by m, so I get rid of m by dividing. So v squared is 2 times kinetic energy divided by m. Now don't let this bug you that I've got this kinetic energy acting as 1 unit. You know, in physics we do weird things. And now I'm going to square root both sides. So the velocity or speed I'm looking for is twice kinetic energy divided by m. Now let's just plug in. 2, what was my kinetic energy? 1.1 times 10 to the 9th joules divided by the mass, which is 8, times 10 to the 4th kilograms. And I get 165.8 meters per second. Now, let's look at these. I like these comparison ones. I have 2 bullets. One has a mass of 3 grams and one has a mass of 6 grams. And both have the same speed. Which one has more kinetic energy? Kinetic energy is 1/2 mv squared. Now the beauty of this one is you don't have to actually do any calculation. If they have the same speed, the one with the greater mass will have the greater kinetic energy. So the 6-gram bullet is going to have more kinetic energy. In one of the few cases, I'm not going to make you do an actual calculation. Now, what if I'm looking for mass? That's another thing I can do. Now I have a car that has a kinetic energy of 4.32 times 10 to the 5th joules. And is traveling at a speed of 23 meters per second. What's the mass? Well, let's look at it. Kinetic energy is 1/2 mv squared. I want to solve for m. Step 1, clear the fractions. So I have a 2 in the denominator, so I'm going to multiply both sides through by 2. So twice kinetic energy is equal to mv squared. Those 2's cancel. I like crossing things out. I'm looking for m, so I want to get rid of v squared. I'm going to get rid of v squared. So mass is twice kinetic energy divided by v squared. Alright, so this is twice. Now I can plug in. Kinetic energy is 4.32 times 10 to the 5th joules divided by the velocity is 23 meters per second squared. And I get 1,633.3 kilograms. like these as well. If the velocity of cars doubled, how is kinetic energy affected and why? You don't have to do any real calculation. Kinetic energy is 1 half mv squared. Just write the formula down. Now, the speed is going to be doubled. So right here where the speed is, I'm going to put a 2. And what am I doing to that? I'm squaring it. So what do I get here? 4. So if I double the speed, my kinetic energy is going to be 4 times.